let us say if you have an ER diagram or entity relationship diagram, then how can you convert this entity relationship diagram into a relation? And when I'm saying a relation means we are going to convert it into a table. So you know what is an entity set. So first step is, if you have an entity like this, for example here employee is an entity, and here employee number, employee name and salary, they are the attributes of this entity. So you can say an entity set is mapped into a relation. That means this entity is mapped into a relation, or you can say it is created as a table, and the attributes of the relation including the attributes of an entity, right? For example, here the attributes are employee number, employee name and employee salary. They will become the attributes inside this table. And if there's a key attribute in an entity, that key attribute becomes the primary key of this table. So if you have a simple entity like this simple entity can be converted to a table like this, right? So you can say for every entity in the ER model, we have to get a relation in the relational model, and this is also called as a relational model. Okay, now let us check out the next one. Now if you have a multi-valued attribute in the previous case, if you have a multi-valued attribute, then those multi-valued attributes should be included in the table. So we are not actually going to include them as it is, we are just going to include the compositions of those should not be included. So that should not be included, that should be there. So we will be dealing with the multi-valued attribute at a later point of time. So right now just assume that if we have a composite attributes means the attributes which can be broken further. For example, you can see the salary can be broken into TA, basic, DA, HRA, etc. And this salary is representing a composite attribute. So you can say if you have a composite attribute, then you don't include that composite attribute, you just include the compositions. So you can say in relational model, don't represent the composite attribute as it is, just take the composition. Like here salary is a composite attribute, but the compositions are TA, basic, DA and HRA. These are the compositions of salary. In the same way, if sometimes we have a name and there are compositions of name are first name and last name, then we are not going to include name in the relation or in this table. We are going to include the compositions of name, that is the first name and the last name. And the attributes of a relation includes the simple attributes for any entity. Okay, for example, here you can see this is a employee number was a simple attribute, employee name was a simple attribute, salary was a simple attribute. In the same way here e number is a simple attribute, e name is a simple attribute, but here this TA is a simple attribute, salary is not a simple attribute because it is a composite attribute. Basic is a simple attribute, DA is a simple attribute and HRA is a simple attribute. So we are going to make this table, the name of this table is employee, right? And in employee we are having employee number, employee name, basic, TA, DA and HRA. And you can see the primary key for this entity is employee number, so that will become a primary key into this here in this case also. Okay, now check this out. Here saying the entity set with multi-valued attribute. If you have a multi-valued attribute, like we see sometimes it can happen, then you are having multiple values. For a student, if I take an entity as student as an entity, a student can have roll number, a student can have a name that can be further divided into first name and the last name. A student can have a phone number. Now this roll number should be included in the relation, because this will become a primary key. This first name should be included, this last name should be included, but we do not include the phone numbers. Why? Because phone number is a multi-valued attribute. Multi-valued means a student can have more than one phone numbers. And we don't include multiple values, because if we are going to include multiple values, then we are going to repeat a lot of values. For example, if you can see, if I have a student Ram and Ram is owning 3 phone numbers, then what can happen? This is roll number, this is Ram, sorry, this is first name, this is last name and this is phone number. So assuming roll number is 1, student name is Ram, first last name is KR and the phone number is 9821 something. Again roll number 1 Ram, last name is KR, phone number is 9560 something. Again phone number roll number is 1 Ram, KR, again phone number is 9912 something, right? So here you can see, if you are going to include multiple values, and because of these multiple values you are going to have lot of duplicate attributes, and because of these lot of duplicate values, or you can say duplicate records, we are going to waste lot of space in the relation, or you can say the table. So that is why we do not include the multi-valued attributes in the relation. We create a separate table for the multi-valued attributes, therefore so that we do not waste the space. So here you can see the employee number is the primary key, or you can say it is a key into this entity. We have employee name and we have city. Now if we discuss about this particular city, the city is a multi-valued attribute because an employee can live in more than one city. So here we are going to create a separate table, and into this separate table we are going to make this employee number as a foreign key. That means this employee number will be referring to this employee number in the employee table, because if there is a value here, then only we can insert a value here, and this will save us from repeating lot of values or lot of attributes. So we are going to make two tables because of this. For this multi-valued attribute we make a different table. We do not include the multi-valued attribute in the original table itself, because that will lead us to a lot of repeating values. So if you have an employee, use the simple attributes or the compositions and the primary key into this table. If you have a multi-valued attribute, for that multi-valued attribute create a different table. Okay, now let us see how to translate a relationship into a table. Like you have this complete is a big relationship. Into this relationship we have this is representing work scene is a relationship. We have entities as employee, we have entities as department, and works in relationship is having an attribute since. That means a employee is working in a particular department since what time. Okay, so in this case a relationship set is mapped into a relation, and the attributes of the relation includes key attribute of the participating relations are declared as a foreign key to the respective relation. Descriptive attribute is if any, and set of non-descriptive attributes is the primary key of the relation. So what do I mean to say here by this is, here you can see what is the relationship here. Works in is the relationship. We can easily create a table for this that we have created here. We can easily create a table for this that we have created here. But here you can see the works in is the relationship, and this relationship is having an attribute. For a relationship you have to create a separate table, and this table will be containing a foreign key from both the relations, both the entities which are participating in the relation. For example, we have employee as an entity, and the key of this employee is employee number, and we have department as an entity, and the key of the department is department ID. So we are going to include them as a foreign key here, and we are going to add this attribute here. So by this way you can easily convert this complete relationship into a relation, right? In the same way you can convert this entity as a relation, and you can convert this department as a relation. See, I'm using a term something called as relation, and this is something called as relationship. So both these terms are different. When I'm saying relationship is like this, works in is a relationship, and when I'm saying relation is this table. So this relation is a formal term and table is an informal term in case of relational model. Okay, now let us check this out. Here they are saying how to convert a relationship set with a key constraint. You can see here in this case it is here this side is having the maximum cardinality as 1, and this side is having the maximum cardinality as many. So here you can say this relation is as 1 to many relationship. Okay, we have already done this kind of examples before. Now each department is required to have at most one employee as a manager. So for this, if you can easily create the relationship sets, that means each department is having at most one employee. At most one employee means maximum one employee is required, right? Or less than 1 is also acceptable, like 0 is less than 1. So here for this employee you can easily create a table for this employee that we have created. You can easily create a table for this department that we have created. But here this manages relationship is not having any attribute, So if it is not having any attribute, then we can, what we generally do is we create a table for this employee, we create a table for this department, and we create a table for this relationship. But because it is not having any attribute, so there is no benefit of creating this table like this. So what we do is we combine this relationship table with this department entity table, because here you can see what is the maximum cardinality of department, that is 1. What is the maximum cardinality of department? That is 1, right? And because it is having the maximum cardinality as 1, or you can say it is having the key constraint, this is the reason why we can combine both of them. And when we are going to combine them, the main reason of combining them is because we want to have as minimum duplicate values as possible. That means we want to reduce the redundant values, or you can say redundant records from the table. So even if we combine both of them, still we are not going to have a lot of redundant values because of this key constraint. Okay, because of this, because the maximum cardinality of department is 1. Okay, and the maximum cardinality of employee is m, so that is many. So the relation is called as 1 to many here in this case. Okay, so now let us take a few examples. Here in this example I've created some relations, and I wanted to ask you, if you are going to convert these relations into this complete AR diagram into a relationship, then how many tables you are going to require? So take the first example. In this example, if you are going to convert this as a table or relation, then you are going to require the first table for this. You are going to require one table for this, or you can say one relation. You are going to require one relation for this, or you can say one table. And for this relationship, you are going to require one table. But here you can see, it is having the key constraint. Right? Because the maximum cardinality of B is 1. That is why you can combine this table for this relation and the table for B. So you can combine these two tables. So in minimum, you are going to require 2 tables only. One table is for this, and second table is for this. You are going to require 2 tables only. Okay, so the attributes in these 2 tables will be like this. In the table A, the attributes will be A1 and A2, where A1 is a primary key, or you can say A1 is a key attribute. In the table B, we are going to have the attribute as B1 and B2, and we are going to have the attribute as A1, and this A1 will be acting as a foreign key which is pointing to this A1. Okay, so we are going to have these 2 tables. Now if you check the next relation, it is a many to one relationship, and here you can see there's a key constraint here. It is the same thing. We are drawing the above table above one like this only. I'm not showing any attribute. So here you can clearly see that we are going to require only 2 tables to convert this AR diagram into a relationship. Now in the next table, you can see it is many to many, because here it is many cardinality, here it is a many, or you can say cardinality is more than 1, maximum cardinality is more than 1 in both the sides. In both the sides we are not having any key constraints. For this purposes, because of A, we have to create a table for this entity A, we have to create a table for this entity B, and we have to create a table for this relation R. So there are at least 3 tables required, because there are no key constraint. But here in the next diagram, you can see that there is a key constraint in both the sides. That means the maximum cardinality is 1 in both the sides, or you can say it is a 1-to-1 relationship. Now in this 1-to-1 relationship, we are going to require 2 tables. Number 1, the first table, either you can combine A and R. So first table can be combined, you can make the first table by combining A and R, and second table can be B, or you can do something like this. The first table is only A, and second table will be combining B and R. So you are going to require only 2 tables to convert the following relational AR diagram to the relation. Okay, now let us take more examples after this. Let us take these examples. Let us see how can you convert, how many tables number of tables are required to convert these AR diagrams. So take the first diagram. Here you can see that it is a 1-to-many relationship, because we are having a key constraint here, and we have already done this kind of example. So we already know that for this example we require 2 tables only. And what are those tables? In the first table, we are going to combine we are going to have a, and because there's a key constant at this side, so you can make it a1, a2, we are going to have this one, and because there's a key constant at this side, so we are going to have, okay, so I did a small mistake here, let me correct it out. I did a small mistake, sorry guys. Fine, so here it should not be like this, it should be like this, because both the examples will be same. Sorry, it should not be like this. Right, now it is representing a one-to-many relationship. Okay, one-to-many, because here you can see the maximum cardinality for B is 1 and the maximum cardinality of A is M. So you generally write it like this. So it is one-to-many ER diagram, or you can say one-to-many relationship. Here you can see we are going to require two tables, and the tables will be like this. The first table, generally what happens is we make three tables. One table is for A, one table is for B, but one table is for relation R. But because it is a one-to-many relationship, therefore for this one-to-many relationship we require only two tables. All this information can be stored only with two tables. The tables can be like this. The first table will be A, which will be containing A1 and A2, where A1 is a key attribute, and the second table will be for B and R, for this combining B and R. So it will be having B1, B2 and A1, where A1 is a foreign key, and this B1 is a prime attribute. You can say it is a key attribute here. Now if you check the second diagram, in the second diagram you can see it is a many to one relationship. There's a difference between above one and this one, so just the difference will be there in while combining the relation and the entity. So you can make AR as first table, and it is having the attribute A1, A2 and B1, where B1 is acting as a foreign key and A1 is acting as a key attribute. And the same way we are going to have the second table, which is containing B1 and B2, and B1 is a key attribute, right? So this is you can convert this AR diagram into a relation. If you check out the third diagram, you can see we are having two A1, A and B. These are two entities, and this is a many to many relationship, right? It is a many to many relationship, and maximum cardinality of A is many, and maximum cardinality of B is also many. So you can see for this A, we can create a table that is A1 and A2, and for this B, we can create a table that is B1 and B2. In the table A1 is the it is the key attribute, and in the B1 is the key attribute. Okay, and then for this relation, because it's a many to many relationship, we have to create a table for this relation, and we'll be having A1 and B1 as the key attributes. That is, these are the foreign key to their respective relations, right? So if we have a many to many relation like this, then we can use this. Okay, now check out the next diagram. Here they are saying this is having one-to-one relationship in both the directions. So if you have a one-to-one relationship, then in this case we are only going to require two tables. We don't require more than two tables, and for these two tables, either you can combine this A with the relation R, so you can make a table AR, which is having the attribute A1, A2 and B1, and the second will be the table B, which is having B1 and B2. This is one way of creating the table, or the second way of creating the table is, instead of combining A and R, you can combine the next table, that is B and R. So you can also make a table like this, A, which is having A1 and A2, and you can make the second table as BR, which is having B1, B2 and A1. So where A1 is a foreign key, so here B1 was the foreign key, and B1 is there as a key attribute. Okay, so this is how you can combine this one. Now if see, you generally get a lot of questions related to this in your examination, so I'm going to take some previous year questions also, and I'm going to try to convert them. Okay, so let us see. If we have a relationship set with a key constraint and the participation constant, the only thing which is differentiating here is the participation constraint. That means here you can see in the diagram that department is having total participation. When do we have a total participation? When the minimum cardinality for relation is greater than 0 or it is 1. So we have already seen this in the previous video. If you face any problem with the terminologies in this video, you can go through the previous videos, and they will really help you out. Okay, so you can see here each department is required to have exactly one employee as a manager, right? So if this is the requirement, so you can see if there is a key constraint, merge the relationship set table with an entity set table. If the entity set table is totally participating with the relationship set table, then foreign key with not null constraint. We are going to use a foreign key with not null constraint. If you check this out, let us see what we have done. If you have a total participation here, then you can see for employee we can create a table for employee like this only, but for the total participating site, we are going to create this department ID. We are going to create the department name, and because it is a total participating site, therefore we have to include a foreign key from this. Okay, see guys, there's a difference between, if I am writing a relationship like this, it is manages, and it is like this. There's a difference between this, and if I show a relationship like this, there's a difference between this. Okay, and what is the difference is, you can see from this side, this entity is having the maximum cardinality as m, and this entity is having the maximum cardinality as 1, right? They are not discussing about the minimum cardinality, or you can say participation is the minimum cardinality. Okay, here not discussing about the minimum cardinality, but here when I'm saying it is total participation, that means the minimum cardinality or participation is 1. Okay, that is why this is like this only. Okay, now let us take the next example. So you can see it is saying if you have a relationship like this, which is having the total participation in both the sides, that is the minimum cardinality in both the sides is 1, then for this table, either you can create a table for this and you can create a table for this, but that is going to waste a lot of time for you. But if you have a total participation in both the sides, in such kind of examples, what you can do is you can combine all the attributes in them, and you can create one single table. That means, assuming that name of that new table is ARB, and it is going to have A1, A2, B1 and B2, where A1 and B1 both combinedly create the primary key of this. Okay, so you can say if there's a key constraint from both the sides of an entity set with total participation, then we represent that binary relationship using a single table. So you can create it as single table in both the sides. Okay, fine. So now let us take this example. It is a previous year question. Now they are asking in this question is, find the minimum number of tables that are possible when you translate the above ER diagram into a relational model, right? So if you translate this, how many tables are required? Okay, so here for the answer is 4 tables are required. Why 4 tables are required? If you can see these relationships between this relationship only. Okay, fine. So for this relationship, we require how many tables do we require for this relationship? That is A, this is the table A and B. Between A and B, how many tables do we require? Because it is a many to one relationship, so we only require 2 tables here. Okay, and fine. So there's a table which is possible for B1. For B, there is a table. You can see for A, it is participating in both the sides. That is, you can clearly see the maximum cardinality is 1 here. So let me write it down like this. For B, you can create a table for this. For B, you can create a table. That is B1 and B2, which is having the prime attribute as B1. And for C, you can create a table, because you can clearly see in both the directions it is having many as the maximum cardinality. So it is for C, you can create a table which is having C1 and C2. Now you can see for A, there is a problem. And there is a problem for A, because A is having the maximum cardinality as M. So sorry, I'm so sorry. Okay, so because A is having the maximum cardinality as 1 in both the sides. Maximum cardinality is 1 in both the sides, right? So because C and B were different, but A is different. Okay, and here what happens to this relation R3? For this relation R3, it is M to N relationship. Therefore, you have to create a table for this relation R3. For R3, you are going to create a relation which is having B1 and C1 as combined as a attribute, where combined as a key, where B1 and C1 both are foreign keys, right? But for this particular A, for this A, you have to create one single table only, and this A can be created by using combining R1 and by combining R2. So we are going to create a table which is A1, A2, C1, B1, where A1, C1 and B1, C1, B1 are foreign keys. They are foreign keys, and A was the key of this. So here in this case we require only 4 tables. We do not require more than 4 tables. Remember this thing. Okay, let us take the next example. So here they're asking, what is the minimum number of tables which are required? Okay, and let us see how many tables are required. So if you have this A, now you can see for A is having minimum cardinality as M in both the directions. Therefore we have to create a table for A. That means there will be a table for A which is having A1 and A2, and this A1 is a key attribute here. Now you can check for this D. D is having many in both the directions. Therefore we are going to create a table for D which is having D1 and D2, where D1 is a key attribute. Now you can see this B is having, B is having 1 as maximum cardinality here and 1 as maximum cardinality here. Maximum cardinality 1 in both the directions. Okay, so for this B we can create a table, but that table will be combining R1, R4 and R5, because here also it is maximum cardinality as 1. Therefore we can create a table for B, R1, R4 and R5. There is one single table which is required for them, and it is having the attributes as B1, B2, D1, C1, A1, where D1, C1 and A1, they are the foreign keys, and B1 is the current key attribute here. Okay, so you can see for this complete B we just have to create one single table. Okay, now if you discuss about this C, there's something interesting with the C, is that C is only having the maximum cardinality as 1 in this direction, but with R2 it is not having the maximum cardinality as 1. Therefore for this R2, because it is a many to many, for this R2 we have to create a relation for R2 which is containing A1 and C1. Both A1 and C1 are key attribute, and for this one, for C, we have to create a relation which is combining by C and R3. It is having C1, C2 and D1 as the key attribute. So D1 and C1 will be there. Okay, D1 and C1 will be there. So this is how you can easily convert a ER diagram to a relationship model. Now you can see here I am representing a weak entity. With this diagram you can see the department is having a weak entity here. Maybe some problem in the diagram. It is a weak, so it is a partial key, and it is representing dependent is a weak entity. So if we have a weak entity here, for this weak entity we can create a table for them, and it will be containing, the table will be containing employee number, the table will be containing employee number, department, dependent name, and we have age, right? So what is there? If you have a weak entity, for that weak entity you create a table, and you have to, this is the strong entity, and this is the weak entity. If you have a weak entity, you want to create a table for weak entity. Okay, before that, first of all understand why is it a weak entity, because this in this weak entity we don't have a key attribute, or consider we could have a primary key. With the help of this dependent name, we'll not be able to identify each record uniquely. Therefore we need the help of some other attribute which is not available here. Therefore we have to take the help of this strong entity. You have to take the key of the strong entity combined with this partial key, so that we can differentiate between each dependent uniquely. So in this case we are going to require 2 tables. Number 1, the first table is for employee. This employee will be containing employee number, employee name and salary, and second one will be for this weak entity, which will be having employee number as foreign key, and we have dependent name as partial keys, we are going to combine both of them to make a key attribute, and then we are going to add age also. Okay, so we require only 2 tables here. Okay, now if you take the next example here, find out what is the minimum number of tables which are required to draw this one. So you can see the minimum number of tables here are 3. Why do we require 3? Is take this example, take this side, it is the many side and it is also a many side. For both of them you can create a table. For E1 you can create a table which is having A1 and A2, where A1 is the key attribute. For E3 you can create a table which is having C1 and C2, where C1 is the key attribute. For this E2, because in both the sides it is having maximum cardinality as 1, you can create a table for E2. The attributes which will be there is B1, B2, B3, A1 and C1, right? A1 and C1. Further, because here you can see the B3 is a partial key, it is not a key, therefore we have to create different tables here. We can either further divide these tables, but if we discuss about what is the minimum number of tables required, that the minimum number of tables required in this scenario is only 3. In this scenario also we require only 3 minimum number of tables. Okay, so whatever topics which we have studied, let me write down in terms of steps. So step 1, for every entity in ER diagram, for every entity in ER model, we have to get a relation. We have to get relation in relational model. Okay, do one thing, write it down. So I'm just not going to write them everything again and again. You can pause the video and you can write down in notebook. The second is, if you have a weak entity, right, and that weak entity is having a partial key, for in that scenario, so we will be having a strong entity and we'll be having a weak entity. You have to create a table for that strong entity, and you have to create a table for that weak entity. And in the table of that weak entity, we are going to add a foreign key from the strong entity, and that partial key plus foreign key is going to make, so partial key plus primary key, or that is actually foreign key, that will make a primary key in that. Okay, now if you have a relationship, so you can easily follow the steps. For a relation, you have to see whether it is having a total participation or whether it is having what kind of relationship it is. If it is having a total participation is one side, now you can add attributes of that relationship into that side only, and you can use it like this. Okay, and you can, this is the way you can convert a one to many relationship, one to one relationship, many to one relationship, and many to many relationship. Okay, we have already discussed all of them. Okay, and when we have the multi-valued attributes, we do not include the multi-valued attributes in the table of that entity. We create a separate table for that multi-valued attributes which contains a primary key. Okay, and if we have some n-array relationship, then we create tables for those n-array relationships also. Okay, so this is it for this. So let us look at the next topic now.